Hello, thank you for joining the session. There's a lot of you. I'm Filip Glavota, technical evangelist, based in Croatia, part of commercial software engineering group. And today I'll be talking about AI, machine learning, how we in a Microsoft view it, and just as an introduction, my segment, commercial software engineering, is working with the customers and partners on the new technologies, uh, mostly on Azure, and we are focusing on cloud. And we are basically um, testing the new services. So mostly we are working in the preview field. And this is one of the examples we did recently, and it was with a customer, Microscope IT, and they wanted basically to use deep neural networks and deep learning to remove the cranes from the images. So you can see on the left side there are cranes, and on the right side there is basically no cranes. And this is something we do. And today we'll try to define what's artificial intelligence, why is it happening now, what's our approach, what we have to offer, and what are the services, and also what's new. How many of you played with machine learning? Just raise the hand. Okay, there's a lot of you. So this term is nowadays widely used, but it usually lacks a common definition. So Wikipedia says it's machines showing capabilities that are typically associated with human intelligence. So there's like three things: reasoning, to learn and form conclusions with imperfect data, or with some data, and understanding, to interpret the meaning of this data that comes from different sources. And the last thing is interaction. So interaction in a more natural ways with the customers or with the users. And what does it mean for the business? It's estimated that 1.2 trillion of additional revenue or shifting revenue will be driven by AI in the next 3 years. And what does it mean for the businesses? It means that you can leverage your unique data in a new ways that you haven't thought of. And the other thing is understanding, so interpreting the customer data and business data in real time, and scale it up from these different sources. So you can use text, images, voice, videos, and so on. And interaction, it means removing the barriers you have between your business and your customer. And also you can multiply the employee capabilities, so make them more productive. And what's happening now, because we know there are algorithms that exist for machine learning for like 25 years probably, but how it started with grand calculator, when we first wanted to make something, the machine better than the human, then a grand calculator, which was mechanical calculator, was made. And then from then on, we got AT&T Voder, which was the first machine that could mimic the human voice, and then so on. And then happened cloud, and that boosted AI. So there are three main things, basically: the powerful algorithms, as resources were invested in the last 5 years, there were some progresses in algorithms. And this is the first thing. The second thing is compute power that is available on your fingertip, basically just a few clicks away in the cloud. Just put your credit card number and you're good to go. And the third thing is big data. So everybody has some kind of data, and big companies have really a lot of it. And there are mechanisms to analyze this big data, and there are data warehouses, there are stores where we can store pretty much big amount of data. So that's the third thing. And how we basically structured it is like in 4 pillars. The first one is agent, which is Cortana, which tracks what you're doing on your machine, if you're using Windows, of course. And then she knows how you interact, how you collaborate, with whom you collaborate, and so on. The second thing is applications that have AI incorporated into them. And the third one is services. So applications are already existing applications. Services are there to integrate into your existing applications. You will see which ones. And there is also infrastructure where you can basically provision everything. CPU, GPU machines, and so on. How it looks like. So in the first part, there are solutions. So it's extensible applications. That means Cortana, you can build a new skill for Cortana and include it and publish it and include it as a part of Cortana and use it. There are also cognitive services that you can use with or without bot framework, which we have. And it's easy to consume intelligence. There are also different data science tools for data preparation, for modeling, experimentation, and in the end, for deployment of these models that you created. We also have deep learning cognitive toolkit. It's a pandan for TensorFlow, which is Google's, and it's widely adopted. And it came from Microsoft Research. And there are some services that you will see later on that are built basically in the CNTK. And the last thing is analytics in big data stores, whether it's on-premise or in cloud. How the stack looks like. So on the top, you can see applications, services. You have cognitive services. You have Azure Machine Learning Web Services, and you have bot framework. And when we come to the frameworks, we have a new service that is called Azure Machine Learning Experimentation Service, which can handle basically any framework, whether it's Python or R, and any library. And also with it, we got model management, which helps you to deploy it anywhere, cloud, on-prem, or wherever. And also there are some other things like also we support Spark and data science virtual machine, which basically you can provision with all the tools and software that you need for the data science work and for machine learning as well. So it comes preloaded with a lot of frameworks, with a lot of different tools for data wrangling and so on. And when we are working with our customers, we are usually using that because the setup of the local machine, if it's not already set up, it takes a lot of time with the drivers and everything. And also we have AI batch training, which is basically if you want to use the GPU for training or for the experimentation, it helps you to use low priority resources. So if you were using VM, you would pay the full price for the VM. And by using AI batch training, you're paying less for the low priority resources in the cloud. That's something worth mentioning. And then underneath is basically infrastructure, the storage where you can store the data, which is like blob, if it's unstructured, SQL database, SQL data warehouse, Azure Data Lake Store, and so on. And of course, there is infrastructure part here. And when we are talking about the inferencing, so you build a model and you want to just use it, and you want to inference, for example, the images are coming to the model, and then you're classifying them, for example. Then basically this model management is creating the Docker image where you can deploy it anywhere. And also there is Azure Container Services, Azure Kubernetes Services as well. And the newest thing is basically Edge, where you can train the model somewhere else. And then, for example, in the industry where you have like different electronics and you're trying to find if they're made all right or not, then you can publish this model to some smaller devices that can work offline with sporadic internet connection. And that's what we use Edge, and we call it at the edge, basically. And when we are talking about the applications which have AI integrated into it, there is Office 365. For example, Outlook has this focused and other inbox, which uses AI and some other things underneath, which gathers the data with whom you are collaborating, with whom you are exchanging the emails, with whom you are communicating over the Skype for Business, Teams, and so on. And then it concludes that something is more important than some other thing. And it works really well, at least for me. There's also some other things. It's integrated into Skype, into Teams, and so on. But there is this one application called Pix. It's an application came from Microsoft Research. It's really interesting because when you press the button on the application, then it basically takes 10 images before the click of the button and 10 images after the click of the button, and then it's trying to find the best images. So open eyes, smile on the face, and some other things, and it presents you 1 to 3 best images that it took, basically in this time frame. And also it does like automatic enhancing, contrasting, and so on and so on. That's something interesting. So if you want to know more about it, you can download it from, if you have iPhone, you can download it, or you can Google it or Bing it. Nobody is Bing, right? Yeah, only in US. Services, we have cognitive services, bot framework, Cortana intelligence, and so on. So what would you use cognitive services? They are basically REST APIs, so they're easy to consume with just few lines of code, and they can integrate into basically any language, any framework. You can integrate it into Android apps, iOS apps, Windows apps. You can use Node.js, Python, whatever. They're built by Microsoft Research, Azure Machine Learning development team, and also Bing team. Yeah, Bing. If you didn't know, the Bing is basically the biggest AI driver in Microsoft, because they are gathering the data. They have a lot of data. Anyway, they have like 20% of US market, but they've been like driving and researching and developing AI techniques for a long time. So a lot of things came basically from the Bing team. And there is also a lot of documentation on GitHub, on Stack Overflow, our docs, MSDN, and so on. How they look like, we split them into few pillars. So it's vision, speech, language, knowledge, and search. And on the right side, there are labs. Labs are the cognitive services in preview. So these are already pre-trained models that you can use. Vision, it can get your emotion from the image or from the video. It can recognize your face if you already pre-trained it for your face, or on the video indexer, it can recognize some like public people. And also you can do the content moderation, so you can see if it's something is presentable to the user or not. And for the speech, speaker recognition, and so on. For the language, there is text analytics, speech translator, and so on. Language understanding service. I saw there was a other session that was basically based on the language understanding service and making a bot, basically. Also knowledge, Q&A maker, entity linking, and so on. And for the Bing, there is like Bing search for images, for different news, video, and so on. And on the right side, you can see labs, but basically I didn't update this thing. So these 4 are already out of the labs, and they are incorporated into Bing Maps API. And they're working really good because I was doing one project with them, and it's really good. And even for the routing, they have like truck routing, so it takes the height also when they're making the route for the user. And for some of those, there are also custom services. So there is a custom vision service, there is a custom speech service, language understanding, custom decision service, and so on. For example, for speech, if you have your own data set and it's some strange accent, let's say, okay, I usually cannot understand the Indian guys or Indian support. So if you have a lot of this data, so you're, I don't know, company that provides support, then you can train it on your data set with this accent, and it will work a lot better than the one that you can choose just like generic one. And how it looks like, so you make a request, you get a response. It says, for the image on the left side, it says indoor with a confidence of 95%. It's some kind of container with a confidence of 80%. And it's a can with a confidence of 24%. And it's not can of beer, it's can of Coke. And you can see on the left side is adult content. So this is used for content moderation. And there is content moderation for images and also for text as well. And it gives you also some kind of category. This is one of examples. If it's gonna work.
What we've done is taken the speech, or what McDonald's with a partner has done is taken the speech algorithm, tuned it, in fact, with this for the specific ambient noise of a McDonald's drive-through. That's that frontier of machine learning and AI. It's not about one speech recognition algorithm. It's the ability to be able to recognize speech in different contexts, with different vocabularies, for different business processes. And that's what really you're seeing. The fidelity of the recognition and the precision is high because of that tuning that you all can do on top of these APIs. But not just that. Not only can you transcribe it in text, you can in fact punch that order directly into the point of sale. Because now that you can recognize the order in text, you can transform it, in this case, into some kind of a JSON object and put it right into your point of sale system. That type of integration of cognitive capability into business process is what we're enabling today. And that's that next frontier, the next platform of the intelligent cloud that we collectively as an ecosystem can and are leading in terms of innovation.
Yeah, and this is not the new video. This is the video from 2015, I think. Nobody saw it so far. Yeah, so what they did is basically they were working with McDonald's in the drive-thru, and there are some different environmental noises, right? The motor is running, somebody is yelling besides the guy who is ordering. There are some people speaking in the car and so on. And if you were watching it carefully, the customer who was ordering basically changed the order at one point, which he said, like, I don't know, I don't want the cheeseburger, I will take like 3 hamburgers or something like that. And on the right side, it removed this order of the cheeseburger and it added new 3 hamburgers or something like that. So that's really, really cool. And I have a demo. It's called, look at it carefully because I will just like switch it really fast. So who recognized if it was muffin or a puppy? For all the pictures. Yeah, not. So it's really interesting. Is it a muffin or a puppy? So I have this demo, which basically says, I have to switch off this. Oh my god, what happened? So we will be using the custom AI service. We'll create a new project. We'll call it Muffin or Puppy. Oh my god, I thought I duplicated it. No? Yeah, so Muffin or a Puppy. We don't need a description. And we'll say, okay, it's some kind of like general classification problem. Create a project. And now I have some images of muffins and puppies. So let's add them here. Okay, so first there are muffins. I have like 7 images. It works on at least 5 images. So put them here. Let's say it's a muffin. Okay. Upload. It will upload it. And then you will say, okay, now I'll upload the images of puppies. And they are here. I did this data set myself. I was searching the images on the web. And I actually did a lot more, but I lost them somewhere, so I had to download it from different service. So this is a puppy. Yeah, it took me a long time because you have to make them like similar. Let's call them similar. Yeah, so there are puppies and muffins. And okay, so you have the data set, you tagged it, you say train, and then the magic happens. And it trains the model. It takes like half a minute, maybe more. So you can set the probability threshold as well. You can do different iterations. You can add another data set of images for different tags. You can make more tags, more classes, and so on. So it says like it's 100%. Yeah. Not so much, but I have also test images, which are okay. Thank you. Which are not included into the training data set. So these are called MT1 and MT2 for muffin, and it says 99.9% it's muffin. And let's do it for the puppy as well. So this one, so cute, and it says it's puppy. So this is like when you want to do fast prototyping with custom vision, you can do it. If you want to make something more complex, you can do it, but it will take you more time. But as you saw, I did it in like 5 minutes, maybe less. Okay. This is the cognitive services. Let's go back to the presentation. And let's switch over to bots. We like to call them conversations as a platform. And when we created the bot framework, we wanted to showcase it somehow. And what's the best way to showcase it than on your support, right? And we decided to make a bot. If you go to support.microsoft.com, you will get a bot that you can talk to. And maybe there will be a real agent in behind at one point. So it enables you human-like conversations. It enables you to integrate this into different contextual dialogues. And also, it's built on top of deep reinforcement learning, language understanding service, basically. And this is the agent's view. This is some application. And the customer comes here and needs some kind of support. And it gets automatically, hi, my name is RGB. And while he's typing what's his problem and submitting it, we are basically parsing this text, and we are suggesting what could be a problem to the agent who is on the other side, basically. And there are like, based on what he's typing, you get like different suggestions. And you can also see there are some other things, transfer to some other person, get the customer in for internal chat. So this bot framework integrates into some other application really easily. And it basically provides you the information of the user. So part of the bot can be automatic. Bot can be fully automatic. Depends on the case. And it can perform some tests as well. It's not just giving the information. You can use the bot, connect it to your system, and do some automatic tests based on the. You can also do the through the Azure Active Directory. You can do the login and everything. So give him the permissions that he needs to have, and then he can do some things basically. And it's already on the GitHub. You can check it out for the login part. And there's also a bot for the Azure subscription, so you can turn on and off virtual machines, different services, and so on. You can also do recommendations to the users based on what he's typing, and also capture information and store it somewhere, so in the CRM or in some other tools, or just in the plain database or whatever. And you can always have the history of the chat and then analyze it later on as well. So how it works? It's an open source SDK. You can find it on GitHub. There is an Node.js version and also a .NET version. And it lets you basically to create some kind of form flow dialogues. And it has support for rich attachments, so, and for Skype calling as well. So you can upload the images, you can upload the voice and do something with it. And it comes with the online or offline emulator. So when you are developing, you can test it locally, and then when you publish it, you can test it online and so on. And also you can integrate different cognitive services inside of it. So one of the main are it's called LUIS, Language Understanding Service, but you can use the other ones as well. And when you developed it, you want to go and register your bot, connect it, and publish it somewhere. So there is a developer portal for that. And it basically, you're developing one bot, and then you are just turning on the channels that you want to use. So we are supporting Slack, Teams, Skype, Messenger, Facebook Messenger, Twilio for SMS messages, and you can also communicate with it over the email as well. So it connects to Office 365. If you have already existing Android or iOS applications, for example, you can use Direct Line API, which gives you the access to the bot as well through directly. And some other things as well. And when you publish your bot, it goes to a bot directory. It's a public directory of bots, and they're published to the bot framework. And then when you go to, for example, Skype, you type in, there is a great example of bot, Skyscanner bot. So when you go and search for Skyscanner bot, it shows up into search. You can add it as your contact. Then you can talk with it, basically. So I want to go to London on 25th of May 2019, and it gives you the offer, and then you say, okay, and I want to go back. So you didn't say it's a return flight, but when you say, okay, I want to go back on, I don't know, day after, then it will tell you, okay, these are the return tickets for your flight. And then in the end, when you choose what you want, it just directs you to the Skyscanner page with this offer that you already selected, and you can purchase it. And also, there are on Bing, there are some other informational bots that you can try as well, so on. So for booking the cinema or something else. And let's go a little bit deeper. Not like that. Deeper means cognitive toolkit, deep learning. So it's open source toolkit, free and easy to use. And on the right side, you can see one of the examples we did with our customers, which is basically recognizing recognizing what's object detection on images in the fridge. And this is one of the tutorials when you go and search for Cognitive Toolkit tutorial. So you can go through it, you will get a data set, and you will train your own deep neural network and see what you get. And when it comes to Microsoft research, there is a competition happening every year, and it's object detection competition on the images on some data set. And in 2015, we won with a ResNet model, which had the first model that was so deep. It had 152 layers, and usually neural networks were made like more horizontally than vertically. So this was the first time that they did so deep neural network, and they basically won against all the big competitors like Microsoft, Google, Facebook, Amazon, Baidu, and so on. And for the speech as well, we achieved, I think it was last year, 5.1 human error rate on the switchboard data set. So it's just like a chit chat, telephone calls, and it's basically, this is the human error rate. So we have a machine that can understand speech as humans, basically. And what's new? What's old as well? Let's talk a little bit about AI development lifecycle, and then we'll go from there. So on the left side, how it looks like, basically, you have some kind of sources. They can be like different, IoT, CRM, whatever. You ingest this data somehow, so you need some kind of data orchestration and monitoring, and then you store it. You can use data lake, or you can use any other storage. And then when you have it somewhere, you can pull it out through Hadoop, Spark, or SQL, and do some machine learning on it. So first prepare the data, and then train it, and then get the model that is like satisfactory for you. And then you have to deploy it somewhere, so you have to serve it. And when you have it deployed, then you can get integrate it into apps and get the insights as well. So we'll focus on this part here, because this is what Azure Machine Learning is covering, but we also have this part on cloud as well. So first, we came up with this Azure Machine Learning Studio. Who used it? Just one person. Great. So this is the software as a service, and it's really good for prototyping. I used it a lot. I did also some projects on it as well, even recently. But it's like graphical user interface. It has plenty of models, so more than 100 models, modules actually. So you just drag and drop from the left side. You can see there are some like categories. You choose which one do you want. So you have some kind of input, and then you added the metadata. So preparing the data, choosing which columns you want, and then splitting it up into training and test data set, and then applying different algorithms. So at one point, you can apply more algorithms and compare it, which one is better. And then in the end, you score the model. So you compare the results that you get. You can see. So this one is going from this one. Usually we don't use 3 parameters. It's called train model. And then you get the result here, and you can see that we are taking the test data and pulling it here. And then it compares basically what you got from the model and what was the real result. And in the end, you can use the evaluate model to evaluate different algorithms. And also it's extensible. There are R and Python modules, so you can write code. There is also SQL module. You can write some SQL as well, SQLite. And in serverless training, you just click run. It runs. You want to deploy it, just click deploy. It deploys as a web service. and that's it. But I mean, there's a lot of models deployed right now. But when we talked with data science community, they told us they love this for the convenience, and it's really cool, but they want to write code because they're used to code, and everybody has its own preference. So one is using TensorFlow, the other one is using Caffe, the third one is using Theano, and there's like plenty of frameworks, and then like different libraries, and then there is R and R libraries and Python libraries and so on. And everybody has its own preference. So, and also they wanted to have different options for deployment, not only like a web service, which they cannot basically isolate. So we came up with this new service that is called Azure Machine Learning Experimentation. This is one service, and model management is the other service. And it connects to Jupyter notebooks, different IDEs. We created a new tool, Azure Machine Learning Workbench, and it's a desktop tool. Yeah, for Windows and for Mac. And you will see it later how it looks like. And also we have Visual Studio Code, where you can write code. Who's using Visual Studio Code? Yes, I like to see that. So there are Visual Studio Code tools for AI. And these connect to Azure, so you can run it on SQL Server as well, virtual machine with GPUs, container services, machine learning server, whatever, on-premise as well, and also on Azure IoT Edge, which we talked about already. So with a workbench, you get to keep the track of the project. So every run is basically a commit in the Git, which is underneath it, and you can track what you changed, and you can track different logs and everything. You can use it locally. So if you have really strong machine with GPU or more GPUs, you can run it locally. If you want to scale it up, you can scale it up to the cloud and scale it out to for the training, for example, using Azure AI Batch, which I mentioned previously. And you also have history tracking as well. So you can go back, you can restore the old run, and so on. And model management is basically the one that creates the container. So it's a Docker image for models, and it lets you to manage, to deploy it, and to monitor those models. Yeah. And you can easily manage the project dependencies. So it's running Anaconda for virtual environments underneath as well. So you can create different virtual environments. For example, you can have Python 2.7 and Python 3.5 and use whichever you want. But it always, when you install it, it always comes with the newest version of everything. You can also do different metrics, get different metrics, different output logs, and so on. And it connects to Visual Studio Code. Even PyCharm is supported as an IDE, and it has Jupyter notebooks integrated into it. How it looks like this. And not just like you have like different workspaces and different projects in the workspaces. You have great examples there as well, which you can run directly from the workbench. You can run it locally, or you can scale it to the cloud. And there are some new data wrangling tools, which basically allow you to rapidly sample the data set. If you have some big data set, you can sample it, understand it, and prepare the data. And it's using Prose for more intelligent data preparation by example. And also, it when you finish with the data preparation, this part, it creates the data frame, which you can use later on in the code. And you can get different metrics here. So medians, scatter plots, histograms, and so on. So how it looks like. let's go here to the workbench. So this is my workbench, and I just want to show you the. So when you go, you can add different data sources. So you can add data source. You go through the form. Say, okay, this is CSV file, and then you decide which data types are the columns and so on. But I already added it, so I have it here. This is the data set for the energy consumption in Serbia, based on like every day, and I worked on this project with them. So here you can see the date, and you can say, okay, derive column by example, and say, okay, I want some different format here. So I want it to be like 0, 1, and then it gives you suggestion, which could be, or you can write your own. So I want this like this, and when I click to some other column, then it says, yes, it applies to every column, and you just click OK and create a new column. And then you can say, okay, I want to rename column, new date. Okay. And you can see on the right side how it happens, the steps happen. So whatever you are doing, you have steps, and you have some different statistics down there. So it's histogram, it's some minimums, medians, and so on, depending on the columns that you chose. And that's the one thing. And the other thing is, let's go into actually the demo, Iris demo. Iris demo is like a classification problem based on the petals and some different characteristics of the flower. You can say which class it is, basically. So we have our data here. We have data prep. You can also change this, for example, to 1. Aristotosa can be class 1, and you can also do it like derive column by example, and you just say, okay, this is 1, this is 2, this is 3, and so on. I see some guys are already sleeping down there. Okay, and then you also have a Jupyter notebook here. You can run the notebook server from here, but we won't go into that because we are short on time. And then you can see here on the left side how it looks like. And this is the score, and this is the sklearn. So this one we are using to create the model. And some, okay, these are like imports and so on. You are checking this, and then you say, okay, load these features and labels, and you say, okay, these are the values. This is the species. So X are the features, Y are the values of the species. And then you make some random features to make the problem harder to solve, because it's really easy. And then you split the data into training and test data set, and you can decide which regularization you will use and put it into the arguments, and then you will parse it here. So if it's default, then it will use 0.01. If it's something else, it will pull it out from the arguments. And then you are using the logistic regression from sklearn, just the training the model, and then evaluating based on the test data set as well. And you get the precision, recall, and so on, some other metrics as well. And then you want to serialize, when you run it, you want to serialize it into some serializable model that you can use later. So you do it like this. You put it into outputs folder, into model, pickle, and that's it, basically. And when you run it, you have runs here on the right side, and you can see all the runs. And this is what I was talking about. This is the different history tracking of the runs. And this one was the last one that ran Iris sklearn. So I'll open this one. And in the outputs here, you can choose the model pickle and save it to the root folder or you can do it actually in the code as well. But to have it here in the history, you want to put it like that. And you can see also compare. You can compare different runs, so you can choose some other runs from the drop-down menu, and that's basically it. You run it. You also run score iris, which basically defines how the input will look like, and you can provide some test data in order when you call it to evaluate it. And then you create the model management. So this takes some time, so I didn't want to do it live, but I will explain it to you how it looks like. So first one is you log into Azure subscription, and then use Azure Machine Learning Environment Setup. You give it the name and the location where it is going to run. And then it says, okay, yes, I want to do it. And I want to create a new environment, and I will do it on this subscription. And then it says, if you want to track the status, then you say Azure Machine Learning Environment Show, and the same things which you used for setup. And then it says, okay, it's creating, and it's still creating. And then it says, okay, it succeeded. So when it succeeds, you do the Azure Machine Learning Environment set for this environment to be the default one. And it says compute set to iris demo, this one. And then you need to create the model management account. So you use Azure Machine Learning account, model management, create which location, the name, and also give the resource group which gets created up there. So automatically it says, I created it here, even though we didn't specify it up there here. So it created it by itself, and it just added RG at the end. And then you say, okay, I set it up, I created the model management, and then when the model management service gets created, you also have to set it here. So you just say, okay, set this model management like this. And then when it's all set up, this is just like basic thing, making the infrastructure work like it should. And then in one line of code, you basically say, okay, create the machine learning service real time. Use this score iris py for scoring the model. And this is the model file which we downloaded. It's called model pickle. And this score iris py, when you run it, you have to run it. It creates a service schema JSON, which is used to define the input. And then you give it a name. So it's iris app. You're using Python and some other dependencies here. But the documentation is really great. So you can take a look at it. And when you create it, you say, okay, it creates it. This takes some time. It runs in the local mode here, but you can also say, okay, run it on Azure as well. I did it on my local machine. It creates the Docker image. It pulls the Docker image to your computer, and then it says, okay, if you want to try it and test it, just put this Azure Machine Learning Service run real time this application, and this is the input in JSON, and that's it basically. And it says I ran it here, and it says it's Iris Satosa. This is one of the classes here. So when you have everything set up, then you can basically just like run it in one line. And let's go back. I just have one slide that I want to show. Yeah, we already did this. We already did this. Yeah, we already did this as well. And so just to recap, if you are going to use Microsoft services, then you have different options. So if you want to consume them, just go with cognitive services and bots. You don't want to create your own. If you want to create your own, you have different options. So there is a visual tooling, which is basically Azure Machine Learning Studio, and it's really easy to use. You can set it up in and learn it how to use it in one day. And if you want to code first, then you have different options, whether it's on on-prem or on cloud. If it's on-prem, you can integrate it into SQL Server or on-prem Hadoop. If it's on cloud, you can use data science, virtual machine, Azure Batch, Azure AI Batch, Azure Container Services, and so on. And when you're thinking about AI and when you are working and developing the models, you also have to think about, is it ethical to do it or not? How you're using the customer's data. Is it just for your business? Would you be proud if it went out, like the case with Facebook? So the big guys are trying to come up with some ethical and empathetic framework for AI design. And that's what we are looking for. And thank you for listening to me. Time's up. So if you have questions, I'll be here or outside.
Yes.
Yeah.